Yazeed to prepare a summary for WireShark software and teach you some basic principle related to that. So Yazeed is with us now and he's ready to deliver his presentation. So welcome Yazeed. Thank you for the presentation in advance.
Thank you,
Professor. We can hand off the mic to you and you can get started. Thank you.
All right. Thank you. How is everyone? I'm going to talk about WireShark. Basically what I've learned from the playlist I watched. So in the beginning, what's WireShark and what does it do? Basically, WireShark is a network packet analyzer, which what it does, it analyzes network packets in a network. So if you use WireShark, you will be able to capture voice packets, replay voice conversations, capture routing updates, and trouble network issues. So if you capture routing updates, it can help you to know what's going in the network, and you can solve issues by it. So WireShark also comes integrated in another application called GNS3, Graphical Network Simulator. GNS3 is a network software emulator. It allows combination of virtual and real devices and can simulate networks. So it's basically a simulation application. Like, let's go to the next slide. It allows you to capture traffic directly within the topology. Not the GNS3 that captures, it's the WireShark that is integrated with the GNS3 that captures data. So GNS3 allows you to build virtual network with components like computer, PCs, switches, routers, and hubs. So in this image, you can see PC1, PC2, switch, router, and a server. In the GNS3, you can do that virtually. You can select how many computers you have and servers or whatever. So it's a really good tool to learn networking. So it also allows you to have a virtual phone called a physical phone. So if you're an expert in network, you can do it. I personally can't, but it's possible. So in WireShark, you can capture voice packets in a network and replay them too. The communication protocol used between the phones and the router is called Skinny. So Skinny is the protocol that is used to allow communication between a phone and a router. When you're using WireShark and you capture packets or traffic, and there's a VoIP communication that happened, you can know from who to who it happened through the IP address and how long it took, and if it's done or still going on. Like I will show you in this example. This is a captured traffic to know what's going on. Like if a VoIP communication call happened, you go to VoIP calls, like telephony VoIP calls. In this example, it shows that there was a VoIP communication that happened and it's done, completed. And it was 21 seconds. And as you can see, the protocol is called Skinny because that's the protocol used for communication with the router and from who to who. And this is the IP address from the initial speaker. So in this example, you can see how many VoIP calls happened. It only happened once in this traffic. It's just an example. Oops. So to actually listen to the voice that happened, you have to decode it first. And to decode, you have to change the protocol to RTP. RTP means real-time protocol. Why is it real-time? Because VoIP is a real-time thing that happened in a real time. And VoIP is a UDP and not TCP. So if you want to decode the VoIP calls, you have to filter first to UDP to not see all the data that you don't need. We filter only UDP packets to make it easier to see what's going on. So we go to this example, write UDP. So that's Arabic. Now it shows only UDP communication or protocol. In this picture, you can see before decoding, see how it is, and now how it will have look like after we decode to RTP. Oh, here. So we go like to any IP address like this. It shows the source of the communication and destination. So we right click it and we hit decode. See, mint is not correct because we know it's a VoIP. It should not be mint. It should be RTP, as we said. And now you can see it looks different. Let's see the picture here. So before decoding, it wasn't RTP. Protocol was different. It was mint. Now it will be RTP. So, and now it shows in the information part that it is G711. G711 is the codec used for encoding analog voice, because a human voice is analog, not digital, of course. So it encodes it. And now we will be able to listen. Oh, I have to go to the next one. Now, you can listen by going to telephony after we encode it, of course. RTP streams. And now you can see in this source, in this information packet, there are two, not once, twice. You might ask why, because it's a unidirectional stream. All calls or all conversations have two streams, sender and the receiver. So we select them and we hit analyze. And now you'll be able to listen to the conversation. Here it says max jitter. Max jitter is like the delay. It says 27 millisecond delay. This is just general information. And hit play stream to listen to the call. Can you guys hear my computer, by the way? I don't think you can. Can someone?
No, we cannot. We didn't hear anything.
Yeah.
But there is something going on, I believe. That's very great. I mean, very awesome. I believe you can hear the voice, yes?
But yeah, I hear you. Yeah.
So you can fix it. Maybe check the mic, the speaker. Check the speaker. Make it external. Or from the setting of the Microsoft team. Yeah, now.
Speaking to himself.
Okay, very great. We heard it. That's
nice.
Awesome. Thank you, Yazeed.
I think the application will crash in a second.
Yeah. Okay. You see, guys, how awesome is that?
Anyway, so jitter means delay. It's just a basic information. You might use it in the future. Did it finish crashing? No. Anyway, in this picture, so OSI layers and TCP are similar. As you can see in this picture, they are the same until like the fifth layer. 5, 6, 7 are grouped into one called application and TCP. Layers in WireShark happen in the GUI, in the program itself. I wish it's not crashed. Yeah, thank you. So in this example, in this picture and below, this is a picture from the WireShark itself after it captured the traffic. It shows 5 layers, which are physical data link, network, and transport, and application. As you can see, it's a TCP because WireShark is a TCP application. Okay, from the beginning, you can see frame 67. Frame 67 is physical wire, or it is the technology itself. So I have no idea about this, like frame 67 or whatever. They're basically the wires or the cables, I guess. And the second layer is called data link. It shows Ethernet 2. So Ethernet 2 is a frame type, and it shows VMware. As you can see in this picture, it's SRC source VMware. So in this example, you use VMware. VMware is an application that is used to virtualize multiple devices on one device. So you can use it to like run Linux on a Mac, stuff like this. So it shows VMware. In application in layer 3, it says network. It says IP version 4, Internet Protocol version 4, and it shows the source IP and the destination, what happened and to who, where it happened, sorry. And then transport, it uses TCP, shows the protocol used for transportation in like this example. And application 5 is HTML, so hypertext transform. It says HTML, so it's an HTML page. So the source requested an HTML page from the server. So WireShark and unsecure HTTP. HTTP is easy to capture because it's clear text. Anything in HTTP that is not secured can be hacked, captured, read, and even exported. Like even the images can be exported. We will show you in a bit. FTP, file transfer protocol, are also clear text, so they are easy to hack. In this picture, it shows in WireShark the content of HTML page. So you can see the title, Networks Toolkit, Networkers Toolkit. It can tell you the body style, the color, and information like this, HTML information, of course. I want to show you an example. So it is possible to export image, as I said before, in the traffic in unsecured HTML web pages. In this example, I'm going to give you an example. A PC1 basically requests an image from a server. So what does a server do? It serves back the image. So in this picture, this is the source, which is the server. The destination, which is PC1. The protocol is HTTP because he requested an HTML page. And here it shows the information that happened. So as you can see, PNG is a file image extension. So yeah, PNG is application layer 5. And so where is this example? We can write HTTP to only filter HTTP pages, and you can see information on the right. So PC1 requests from the server PNG page. So he opens a page in the website, and here the server answers and gives the picture. So here, layer 1, layer 2. When you see Ethernet, by the way, it means that there's actually a traffic that is captured. Ethernet 2, layer 3, layer 4, and layer 5. And this is also layer 4, transmission, transport, segments, data. Layer 5 application, you can see portable network graphics. So basically says there's an image captured or served to the PC. To export that image, you can see that image. If you capture the image, you can see it if it's HTML. We can export it by right-clicking, and there's, I believe, export packet bytes. I will select desktop, and because we know it's a PNG, we save it as PNG. Yeah, here. So this picture came from a captured HTML page. So say goodbye to privacy if you're using HTML that is not secured. So to use WireShark, you should know network, at least basic network, because in network, data travels in ways you have to understand. No, why do I do this? So in WireShark, we should know how traffic flows on the network and make sure that we are capturing the right part of it, of the network. So there's an information that says switches usually floods data to all ports. This is a switch. It gives information to all the ports until it knows the MAC addresses that are involved in a conversation. So like if PC1, if the switch knows the MAC address of PC1 and the server, and PC1 requests data from the server or a web page, it will only send information from the PC port to the server port and back forth. So if you capture like data in this side or this side, you will not see anything. So if you have like a monitoring station, let's say Ubuntu 1 is your monitoring station, and you are capturing here, you will not see anything unless there are two solutions to this. So switch doesn't flood data unless floods data to all ports if it doesn't know the MAC address. But if it does know the MAC address, as I said before, it only moves data here and here. So you have to replace the switch to a hub. Hub always floods data to all ports. He doesn't care. Or you have to span the port, which means mirror the port. You have to span all the ports in the network and put it in here, like make a mirror basically. And you only capture in one direction, which is at the Ubuntu cable information. So this is here's general information. Telephony service is what allows phones to communicate with the router. So to communicate with the router, for the phones to communicate with the router, it uses telephony service. Port 2000 is a control protocol that sets up communication between the phones and the routers. In WireShark, you can use display filters as I used before here. Like if you write HTTP, this is filtering. And there are two ways. There's this one, and there's another one here. You go capture options, and you write HTTP only, and start. But this has to happen before you actually start capturing. So why would you do that? So if you do it before you start capturing, this will like listen the bandwidth by miles. So if you are in a big network and you only want to see what like VoIP conversation happened, you can only record VoIP conversation protocol. So you'll only see the VoIP, and the data will be much reduced. So you can filter while capturing or before once the traffic is captured. So each type of filter has its advantages and disadvantages. I don't really know what they are. But as I said, see, in while capturing, it reduces traffic data size. So WireShark supports pre-configured profiles, making it easier to work on a specific goal. Like if you look bottom right, my screen is small. You can see there are pre-configured profiles. You can save, like it only shows Bluetooth or whatever you want. You can change it, edit it. What is Linux? I mean Linux. Linux knowledge is important if you want to be a good network engineer or ethical hacker, especially Linux Kali. So most cybersecurity and ethical hackers use Linux Kali. Why do I write this? And in Linux, you don't use T-Shark. T-Shark is a non-GUI, no graphics. It's just a CMD, like in this picture. You use it to capture traffic. And you use another application, which is the same like WireShark, but it's just a branch of it, you can say. TermShark is also an non-GUI application used to view captures. So you use this to capture data and use this to view them. It's like in this image, CMD. Okay, that's all did for this presentation. Thank you very much.